Greetings, Professor McKee here, and welcome to Seminar Saturdays. This week's paper is called Big Data and Bigger Firms, a Labor Market Channel. Standard disclaimer that I'm going to mangle someone's name here. This is by Abhinav Gupta, Nishesh, and Elena Simintzi. This was presented as a working paper at AFA 2025, so as of this recording, this is an unpublished paper. And I was at that presentation. I saw this paper there. I thought it looked pretty interesting, so I decided to include it in my seminar series. And this is a rare paper that looks at non-executive employees. It also has a pretty novel data set that I don't know if anyone's ever used before. We typically don't look at non-executive employees very much, in large part because it's hard to get information on them. There's a lot of information you can get about the CEO of the company or the board of directors, and there's not much we can get about some random software engineer working for the company. But thanks to social media, we now sometimes are able to get more information about these non-executive employees, and we're able to work in it. I actually have a paper myself that I've been working on that looks at non-executive employees using social media too, which I will link to the SSRN page for that in the video description. Now this paper looks at information asymmetry, and I will briefly go over what information asymmetry means, at least in this particular context. So let's pretend we have two people that are doing a negotiation. We have an employer interviewing a potential employee. Both sides here have private information about themselves that the other side doesn't know. And the hiring manager knows things about what's the maximum salary I can give someone, what's the salary I want to give this person, what kind of work are we going to expect this person to do, how good are the growth opportunities for the company next year, a lot of internal things about the company. The potential employee knows lots of internal things about him or herself. The employee knows how productive, what's the employee work ethic, does the employee plan to stick around or leave, or plans to leave quickly, various things like that. And that difference in information is the asymmetry part. That's where we get the information asymmetry, and if we can reduce how asymmetric the information is, it's easier to come to an agreement. So being able to credibly signal the information, your private information, helps reduce that friction and it makes transactions easier. So the research question that the paper looks at is, how does an objective signal of employee productivity affect the labor market transaction? They're going to use GitHub to do this. And so we have a new signal of employee quality. Who benefits? They argue, they think there's some reasons to think that it is the large firms who benefit from this better signal. So these large firms are going to get higher quality employees. They think it's the case because large firms have reputational and monetary advantages. So let's say I tell people I'm a software engineer at Google versus I tell them I'm a software engineer at a company you've never heard of. I sound more impressive if I'm working for some big famous company. People like to sound impressive. So there's reputational advantage to being an employee at a famous company. Big companies tend to be able to pay more money. And if you get paid more, people like that too. So they can outbid effectively smaller firms if they know who they should be bidding for. And that's why the better signal helps them more than the small firms. Small firms know who to bid for too, but small firms are going to get outbid. They also think there might be economies of scale. So a big firm is going to be hiring a bunch of people each year. They can take this new signal and incorporate it and benefit for a large number of recruitments. Small firms are hiring maybe one person or nobody. And therefore small firms can't benefit as much because they just can't use it that much. There could also, however, be diseconomies of scale, because big firms, big organizations tend to have a lot of additional rules and procedures they have to follow. And there's a lot of hoops you have to jump through to implement this new signal of quality, whereas a small company might not have these rules and procedures and can just move quickly, immediately implement this. The higher information that the company now has lets them weed out bad employees more easily. They can tell your quality without, thanks to this new signal. And so they can know you're a bad choice, we don't want you. Now this benefits both firms, regardless of size, big firms and small firms both benefit, but more people, because they want the reputational and monetary advantages of working at a big firm, are going to target big firms. So big firms need to weed out more people than small firms do. So this ability to weed out people is more beneficial for them. That's the argument. Now, we have some endogeneity issues here. People are making a lot of choices. And wherever we have choices, we have potential problems. So people choose to use GitHub. Not everyone uses it. And they also, probably more importantly, choose to make their contributions public. You can hide what your contributions were, which means just looking at contributions by itself is not very useful because it doesn't actually signal. It's not a great signal because everyone knows you can use this as a signal of your quality, and so everyone can manipulate it. The only thing you can really see looking from the outside is how many contributions you made. Well, so let's say I make a proposal change to the code for a project, and it's a really big one. It's really impactful. It does a lot of things, and it works. It gets approved. It's a big deal, but it was only one contribution. If I break that contribution up into 10 pieces, all 10 pieces are the same as one contribution, and all 10 get approved, I get 10 contributions instead of one. What you really want to see here is that people were previously making contributions to GitHub, but it wasn't public, and they had no ability to make it public. And so in that case, their work creating that data actually reflects their quality. It doesn't reflect their quality and their ability to game the metric. Because at the time of the work, the data was useless for them in terms of signaling purposes. Okay, so GitHub, let's do a brief description of how this works because it's going to be relevant to the approach they use to avoid this endogeneity issue. So it's a web platform. It's widely used in software development for version control and collaboration. The way it works is there is a project. Users can submit and propose change. The person who is running the project manager effectively, will choose if it gets implemented or not. If it does get implemented, it gets accepted by some third party who is in charge of running the project, then it gets recorded as a contribution. So there is an outside check on quality. The project manager, you can't get a contribution unless the person agreed to it. Public repositories, they are open to the public. Any user can propose a change, and if it's approved, it'll get added to the project and you get a contribution. Private repositories are not open to the public, so you have to be allowed into the project, and then you can propose changes. Again, those proposed changes still have to be approved by the project manager. GitHub includes a brief social media profile, which includes your employer and links to your LinkedIn profile. And it tracks your contributions, which results in that potential measure of work output. How many contributions have you made? How many contributions do you make per year, per week, per month, whatever? This is how employees can signal their quality. Basically, the idea is if you have more contributions, that means you're more productive. There's issues with it, of course, but they do find that it correlates with things like salary, publications, funding from venture capital firms, so other people who are evaluating that employee based on how much money they're willing to pay the employee, or if the employee's work is worth publishing, have agreed that this person is more productive than average. So their strategy here is, well, GitHub basically did the ideal thing for us, which is GitHub in May 19th, 2016, changed to allow people to display their private contributions. Pre-May 19th, nobody could show their private contributions. They can always show public, but they couldn't show private. So information from the public contributions was contaminated. There was always a possibility of you gaming that thing to send false information. But the private contributions before May 19th were made without expectation of it being used to signal your quality. Now there's a key assumption here, one that the paper doesn't really do much to deal with. If I was putting on my referee hat and saying, hey guys, can you do some tests to help me believe that this was not something leaked? Because the problem here is if it leaks, then people can start gaming their private information, their private contributions before GitHub makes the official switch. So is there evidence that GitHub prior to May 19th suggested the switch would happen? Is there any anomalies in the data of private contributions in the months leading up to this change? That's what I'd be looking for. Now their data sources, there's a whole bunch of them. So they look at the public profiles of GitHub users. There's a company called Human Predictions, which they use to grab them. This includes links to their LinkedIn profile. The GitHub API gives you contributions of users. They use Revelio Labs, another company, to get LinkedIn profile information. And they link those all together. And if they don't have a LinkedIn link in the GitHub profile, they also can use name and work history to try and get that too. They track the job changes every quarter based on the LinkedIn profile history. That's part of what I did in my own paper too. They have employment through LinkedIn, and then they can get information about that company because they know the name of the company, and they link it to FactSet, and then they get financial information through FactSet or CompuStat. They limit it to people who had at least one contribution before the change in May 19th, and who were already working at a company before May 19th. They're looking at job changes, and so your first job out of college is not a job change because you didn't have a job before. I guess technically it's a change, but they're looking for people switching between companies. They end up with 380,000 employees, 103,000 firms, so that's large. There's a lot of people in here. They do have a few additional, more minor filters, so our numbers will be smaller than the 380,000, 103,000. Now, where were these employees? Well, unsurprisingly, they're highly concentrated in major cities. So Los Angeles, Chicago, New York City, Boston. Those are places with high concentrations. Also, Amarillo has a few people, but not that many, because we're not a major city. And then tech hubs, so the Bay Area, Seattle, those areas also had pretty high concentrations. Again, very unsurprising. We're talking about we're talking about tech companies here, and tech workers are highly concentrated in cities and tech hubs. They have some demographic information about the employees as well as the firms. Again, there are a ton of software engineers in their sample. They have a lot of them, and a lot of them live in San Francisco, New York, or Seattle metropolitan area. Again, very unsurprising. There's not a lot of weird things in here with their demographic statistics. To test the validity of their contribution, they do look at how much you can explain your private contributions based on the individual versus based on the employer. So the personal fixed effects, so the things that are coming from each software engineer, that explains 66% of the variation in private contributions. And only 8.5% is coming from your firm. So just because your firm is different, that's not really going to change your private contributions prior to 2016 May. So this is really being driven by who you are, not who you work for. Okay, so again, we would like to see, at least I would like to see, some evidence that there was no leakage. They don't really look at that very much, but they also look at things like you can choose to reveal your private contributions or not. So is there anything going on there that's causing the results they find? Also, they're looking at differences following this May 16th change. If something else changed productivity in general, then that could drive the results instead of just a better signal. So they look at other measures of productivity. Those measures of productivity should also result in job changes if it's purely people became more productive because of some other reason. So while they have an increase of job changes with the private contributions, when they look at public GitHub contributions, starred contributions, which is where the project manager gives you a pat on the back, salary, academic publications, none of these seem to result in higher job movements following May 2016. And they also say there's no evidence of major tech news in the days around that, in the days around this event. And if they look at people that are doing private contributions, so users with at least one private contributions, or with at least 10 or more, that are working at firms with at least one contribution or at least 10 or more, and they find they're still getting that increase in job movements to the large firms, regardless of how they are constructing, regardless of them limiting to only people who reveal their private contributions. And this is to deal with the potential issue with private contributions being revealed as a choice by the employee. Again, what about the info leakage? I don't see anything for that. As far as I can tell, there's a lot of tables in this paper, but I don't see anything that really helps me here. And I'm not convinced limiting to just what people with private contributions really deals with that potential. So I would really like to see, was there any anomalies with private contributions right before May 2016? Was there any news reports by GitHub or other people following GitHub mentioning this possible change? Because if that is happening, then they got a problem. Hopefully it's not true, but that's what I would want to see as a referee. Now, what are their main results? Well, they find that people with high productivity, as measured by their private contributions pre-2016, when we interacted with the post variable, which is this after the shock, they move to large firms. They are more likely to move to large firms. They include all sorts of various controls here, and their results are pretty stable. It's about 0.12 or 0.17 across the board. So people are moving, and they're moving to large firms. They're interpreting this as saying, well, the large firms are doing a better job of grabbing these high productivity employees versus the small firms. Because the small firms and the medium firm size, they are not gaining employees. They're losing them, actually. People are less likely to move to these guys if they have high productivity, again, as measured by that private contribution amount. Now, to put the pieces a little bit here together, again, they look at job changes to large firms, and they're doing triple interactions now. So the productivity, it's post the change in the rule change, and you're currently working at a mid-sized firm or a small-sized firm, or in the case of no triple interaction, the remaining, which is the large firm. So people at large firms are not job hopping as much to other larger firms. They don't really mention this very much, but I think this is actually a signal that these larger firms are doing a better job of retaining people. Perhaps because they're able to recognize the quality of their current employees. And so their current employees are rewarded more if they're more productive, and so they won't want to leave. Meanwhile, if you're at a mid-sized firm or a small firm, you do move to those large firms more often. Okay, so in addition to job movements, do the newly revealed high productive employees receive other recognition? For instance, are they more likely to receive a promotion? Because that usually means you get paid more, your title is more prestigious, things like that. And because they can see job titles through LinkedIn, they can know if this person has an increase in their job title. So promotions and movements. So people at large firms moving to another large firm are less likely to get promoted. Again, I suspect this is a retention story where you're going to be internally rewarded, so you don't need to move as frequently if you want to get a higher salary, a higher promotion. But if you're at a medium firm, or a small firm, moving to a larger firm and getting a promotion is more likely to happen. You are less likely to move to a smaller medium firm to get promoted if you're at a large firm, but movements between small and medium firms seem to be increasing too. And then within your firm, at a large firm, you're more likely to get promoted. Nothing's happening with the medium and small firms. So sort of putting those together, movements to moving and getting promoted, going to a large firm, the small and medium firms, that's happening. You're not going to do it as much if you're at a large firm. So again, that is a sign of retention. And then if they're for medium and small firms, they are losing their best people to the large firm, and the people moving to the large firms are getting promotions. Large firms are also promoting more people within their own employees, which is perhaps part of the reason why they're able to retain people more. So everything here is very consistent with the large firms are scooping up these employees. They're not losing these employees to the small and medium firms. There's some movement within the small and medium firms where people are shifting jobs to a different small or medium firm too to gain a promotion, but there's a lot of action going on with the large firms. Okay, so another interesting thing that I could look at is substitution. So we have other ways to signal employee productivity. Things like your work experience, what degree you have. Did you go to a prestigious university, which is going to filter in some part on your potential productivity. So they look at the number of years worked, number of years of education, and did you go to a top 20 ranked school? Because if we have this new signal of employee quality, the value of these three signals, work experience, education, degree, the quality of those signals will go down because we are in fact substituting that quality for something better. And so they have interactions based on if your experience is below the median, if your number of years in school is below the median, if you don't have a degree from an elite school, and if your state has a weaker non-compete agreement enforceability. So it's harder for your current employer to block you from moving and working somewhere else for a competitor. What they find is that people below median with experience do indeed see increases in their job movement in addition to just everyone's increase. Same thing with fewer years of school, not going to elite schools, and less enforcement. Now these results are kind of weak. You can see it's only one star, despite having a lot of observations. So the results are not super strong here, but again, this is just sort of an additional triangulation. They also look at some firm characteristics, because some firms might be better at exploiting this new information even within large firms. So if your recruiters in HR are familiar with GitHub, they're probably more likely to implement this new private information. If your firm overall is familiar with GitHub, so anyone in your firm uses it, again, more likely to use this. Also, some things make firms more attractive to ambitious employees, high productivity employees. So if you have high wage growth, historically, if you also have high job risk, historically, because that means high risk, high reward, you might be more attractive to these very productive potential employees. And so they find is that if you have any HR person who uses GitHub, you see an increase. You see an increase either way, but the magnitude here is quite a bit larger. It's 0.0014 versus 0.0003. It's almost an entire order of magnitude larger. If your company uses GitHub, again, it will matter either way. But if at least one person uses GitHub in the place you're moving to, the magnitude of the effect is larger. Oh, and they're comparing the coefficients down here. So there is statistically significant difference in the coefficients for all of these ones. And I look at the career growth. So this is about the wage, how steep the wage increases are. High wage increases, again, stronger effect, and low stability. So there's a lot of risk, which also means typically is going to mean lots of reward. That has a big increase too. And again, these coefficients are all statistically significant. This t-test here is comparing the beta on yes versus no. Tech-savvy recruitment, GitHub usage, this is a dummy variable, as in, do you have someone who uses GitHub or not? The career growth, the wage growth, and job stability, this is an above median, below median metric. So above median wage growth and below median stability. And finally, firm outcomes. Did these large firms perform better because they have better employees? Did small firms perform worse because they have worse employees? And medium firms also too. Well, they look at what happened with employment. So employment growth increases, at least perhaps. It's statistically kind of weak for the firms that are large. Negative but insignificant for our medium firms, and a pretty strong negative effect on employee growth for small firms. And small firms have an increased probability of 50% layoff or higher. So 50% or more of their employees leaving is a lot higher. Well, statistically, it's very strong following this change. Nothing for the other two types of firms. Is there changes in public contributions, which is sort of a measure of quality? Well, large firms see an increase in the total number of contributions as well as their ranking. If they're ranked in the top 10%. Small firms see a decrease. Medium firms, nothing happens. Per capita, public contributions to GitHub goes up, at least in raw numbers for large firms, and then there's a decrease in raw numbers and in their rankings for small firms. So there's a lot of problems for the small firms here. Strong evidence that the small firms underperform. A little bit of evidence that the large firms have better productivity. Now again, these are all GitHub type measures or just raw numbers of employees. This is not things like their net income went up or their positive cash flow went up or other things we often care about in finance. All right, so overall, this is a very nice paper. It's got a really great novel data set, a pretty novel question as well. Not many people have looked at rank and file employees. So I suspect this will publish well. Novel data sets and novel questions tend to do well, tend to result in your paper doing well. My two main critiques of the paper as it currently stands is they are doing a number of things where they're splitting at the median. I didn't really poke on this too much when I was going through them, but just to go back, we are splitting at the median for productivity greater than median for some of these triangulation things. like this career growth and high stability. This is at the median. Now, these results are not necessary for their main finding of job shifts, but I'm kind of curious, like what happens when you split by terciles or quartiles, or you look at the top 10% versus the bottom 10%. There's a lot of ways you can split samples, and while they're very consistent and always picking median, which is good, they don't really have a perfect theoretical reason for why median is necessary. And this is something I just will probably highlight on a lot of papers, because this is just sort of a pet peeve of my own. But I think to make this paper better, you'd want to at least be able to say, yes, we did some robustness tests, and it doesn't matter how we split it, we're still seeing similar results. And then a bigger problem is, was there any evidence that GitHub leaked the change before it happened? And in particular, I would look at, are there anomalies with the private contributions immediately prior to this May 2016 change? Was there any evidence of news articles about this potential change? And some additional tests that I was interested in seeing, but they didn't actually do. They looked at employee productivity following the job movements, but like what happened with the overall firm performance? They should have some publicly traded firms in their sample of large firms. Does revenue go up? Does net income go up? Operating performance? What happens with all your normal financial ratio type things? Maybe they tried it and they can't get anything, because there's not going to, the vast majority of their companies here are going to be private companies. But I'm curious about that. And I think there's a number of firm and employee characteristics they could use that they didn't. So most of their firms here are going to be tech, but not all of them. There's some firms in here with these employees who are not in tech, and so do firms that are in the tech industry, do they benefit more from this signal? Or maybe they benefit less because they already know how to evaluate people. But if you're not in the tech industry, it's harder for you to do a good job of piercing that information asymmetry problem. I don't know. It'll be interesting to find out. Are there more employee characteristics they can use here? Maybe there's some potential to use those employee job titles. Are employees switching to software engineering type titles after they have their information revealed? Does this benefit employees that had bad signals, right? Like maybe the employee had a non-computer science degree. Someone majored in history, and they were also doing lots of contributions on GitHub. Are they more likely to move than the average person who probably did have a computer science degree? I don't know. I'm not sure if they know the major, although I suspect with LinkedIn profiles you usually do. But I think there's more that they can look at with employee characteristics and firm characteristics that they haven't done yet. Maybe they'll do it in addition with an additional paper, because this paper is very long already. Or maybe they add it to this paper. Or maybe they don't, because they don't watch this video. Okay, so that is everything for this paper. And next week we will continue, and it'll be an older type paper, one from the accounting literature, but a very interesting question and one that is very relevant for us in finance. See you then.